Okay, gang, this lesson here is picking up on day 2 in our sequence and series lessons. This one is intended to be viewed on April 7th, and this will be our AMI day number 13. We talked on the previous video, which I'll say yesterday, even though I'm making this on the same day, about sequences and series, and the next 2 lessons are going to be on 2 different types of sequences. So today's lesson is going to be devoted to the first type, which is arithmetic. So we're going to be talking specifically about arithmetic sequences. What makes an arithmetic sequence, what gives it that name, what sets it apart, makes it different, is that it has a constant difference from one term to the next. So if I went back to one of the sequences that we looked at from yesterday, I would say this has a common difference of 2. Okay? Because 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 7 is 9, 7, well, let's try that again. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. So to go from one term to the next, you're adding 2 every time, and that's easy, baby stuff, no big deal on that. So, but if it's being added or subtracted by the same thing every time, it has a common difference, whatever it's being added or subtracted by, and that's what makes it an arithmetic sequence. Because the next lesson, which I'll call tomorrow's lesson, is going to be called geometric sequence, and it's something different. Okay, but when it's being added or subtracted by the same thing every time, it has a common difference. We call that the D, the common difference. Arithmetic's being added or subtracted by the same thing. So I've said that several times. I hope you've made you a note or have it in your brain what we're talking about there. Okay, now, lots of times you can figure out the next, like if I asked you for the next 3 seat numbers in this sequence, you could figure that out pretty simple. You know, 9 plus 2, 11 plus 2, 13 plus 2, and you could keep going that way. But what if I asked you, for example, for the 100th term in that sequence? Are you going to want to write out 100 of these numbers to find that 100th term? Well, you could. You could also watch paint on the wall dry. That would be pretty boring. So, luckily, someone long before us has figured up a formula, and I'm going to give that to you now. And there are going to be lots of formulas throughout this unit, so make sure you keep them labeled well. So since this is our arithmetic, I'm going to write that again for you. If we've got an arithmetic sequence, we can use the formula that says A base N is equal to, so that means any term in the sequence is equal to your first term, A base 1, plus the number of the term you're looking for, minus 1, times the common difference. And we just talked about the common difference on the previous page. So if I gave you this sequence here, let's say I gave you 2, 5, 8, 11, 14, dot, dot, dot. I gave you that sequence, and I want us to find the 67th term in that sequence. Now I could, and you could too, you could keep adding, you know the difference, it's adding 3 every time. You could keep adding 3 and keep that pattern going and going and going until you've listed 67 numbers. You could do that. It's not impossible, and it wouldn't take some of y'all very long. But let's see if we can figure out how to use this formula here so that we don't have to list out 67 terms to get there. Okay? So what we're dealing with here, first off, you need to know it, but the D. Okay? So you're looking to see what's happening in between each of these numbers. First off, does it even have a D? Because it could be just a string of numbers that's not the same every time. So we would say from 2 to 5, that goes up 3. From 5 to 8, that goes up 3. From 8 to 11, so everybody agrees that our D is 3. So we've got a D of 3. Okay. Now, A1, A base 1, A subscript 1. That's the first term in the sequence. That subscript 1 always is your first term, so the first term in our sequence would be 2. So looking at everything we need up here, we've got an A1, we've got a D. Do we have an N? What do y'all think? Do we have an N? I think we do. I asked you for the 67th term in the sequence. So 67 will go in my N place there. okay on that? So I'm going to say the 67th term, I just plugged the 67 in here. I'm rewriting this formula and plugging in what I know, is equal to my first term, which is 2, plus n minus 1, so 67 minus 1 times d, and our d was 3. Now this is just some basic math that we've got to work now, so we don't have to spend our time writing out 67 numbers. I know I'm going to use my order of operations, so that's a 66. And then I got to figure out what 66 times 3 is. Okay, so I've got, so far, let's make some notes and keep going what we've got. 2 plus 66 times 3. Okay, so 2 plus, let me do my 66 times 3 over here, 198. So the 67th term would be 200. Okay, is that what y'all got? I believe so. Alright, so not a whole lot to this lesson. So I told you on yesterday's that I'm keeping them short and sweet for you. So I'm going to go ahead now and go to the next page and give you your assignment. Like I said, this will be April 7th assignment, which will be our 13th. Is that right? Let me go back. Yes, our 13th AMI day. Okay, so we've got 6 problems for you again. And I'm going to do the first one with you after I get them all written so I can make sure you know what I'm asking for. But you're going to write the equation. That's what I want to make sure you understand how to do. Write the equation and then use that equation to find the 10th term. Okay, so for number 1 here, we've got 3, 7, 11, 15, 19. Okay, so if we're going to write the equation, A base n is equal to, what's our first term? 3 plus n minus 1 times our d. What's the d here? 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 4 is 15, so our d is 4. Okay, now that technically is an equation, but we're going to go ahead and clean that up a little bit. I'm going to distribute this 4 here. So I'm going to say A base n is equal to 3 plus 4n, distributing the 4, minus 4, and then you can combine those like terms. So for my first answer for number 1, A base n is equal to 4n minus 1. That's my first answer for number 1. Then to get my second answer, I'm looking for the 10th term. So all I have to do is plug the number 10 in for the n. So 4 times 10 is 40. 40 minus 1 is 39. So my second answer would be the 10th term is the number 39. Okay, so you're only going to have 6, and that was number 1. So you got to rewrite that number 1 on your paper. But I wanted to make sure you saw how to go and get your equations. Okay, so I'm going to scroll that up, and you can go and pause it on the video or run it back on the video. But to write the rest of your assignment, number 2 is 13579. You need to do the same 2 things that we did up there. You need to write the equation like in this form, and then you need to tell me the 10th term. Number 3, 4, 9, 13, 17, 21, 25. Number 4, 6, 16, 26, 36, 46. Number 5, 8, 11, 14, 17. And number 6, 7 1/2, 7 3/4, 8. Okay, so for all 6 of these, you're going to have an equation that you do your distributing and you combine your like terms and you simplify it down so you can see that's actually in linear form, mx plus b. So you're going to have your equation and then you're going to find the 10th term using that equation for all 6 of these.